Guys, I am here to discuss the principle of zeros here. Essentially, we apply this many times when we are factoring, like I've said previously in other videos. So I'm just going to jump into this. I'm going to solve this problem just the way it is given to you in your homework. So this is part of our study plan. It could be part of your homework as well, but I pulled this from your study plan. It says solve the following. And what I notice is that this is a quadratic equation, right? And out of habit, I know there's a few things, there's a process that I go through mentally when I'm solving quadratic equations. The very first thing I do is I ask myself, is this equation equal to zero? In this case, it is not. So what I would do is rewrite this equation so that it has zero on one side of the equation. So I'm going to change my pen color to red. Give me just a minute. And I am going to move this 35 to the left of that equal sign, which would give me 12v squared. I'm not comfortable here. So minus 13v minus 35 is equal to 0. So why do I have minus 35? It's minus 35 because really there's two different ways you can look at this. And now that we're in college, instead of just subtracting the 35, you can just try to mentally understand that when I bring that number across that equal sign, that the sign changes. The reason that it changes is because I did subtract 35 from both sides of that equation, which left me with 0 on the right hand side and just a minus 35 on the left hand side. But as a shortcut, I just draw those arrows. I slide that 35 to the other side and change the sign. Okay. So let's go back to my mental processes. So the first thing I did is I make sure it's equal to 0. My quadratic equation is equal to 0. Go ahead. The second thing is, do I have a greatest common factor? If you have one, you should always factor it out. In this case, I know I don't have a greatest common factor because that middle term there is 13. 13 is a prime number, so I don't have to worry about 12 and 35. If they have common factors, it doesn't matter. I don't need to try to factor them out. Um, but what I also notice is that it is a trinomial, which I've already kind of mentioned, and that my a in this case, my a is not equal to 1. And I would write that down if you're taking notes. A is not equal to 1. So there's different process that I have to go through when I factor a trinomial when a is not equal to 1. There's different ways I've taught this, guys, and this is still the same steps that I've always taught, but I like to do what I call the star method. It's still just old school factoring, but it just sounds different, and it gives you a tool. It gives you a little tool where you can just place things so that you don't forget any parts of this factoring process. So I want to draw the star out. It's not really a star. It's more like the asterisk. Some folks call it the asterisk method. I'm just going to call it a star. I know it's not one. But the star method, I'm going to label it first, show you what goes in the star, and then we're going to actually use the star. So on the sides here, let's color code this. Let's use blue. Let's make it a little bit bolder. On the sides of your star, you will always put your A's, okay? The coefficient for that first term when you have your trinomial in descending order. At the top of your star, what you're going to do is you're going to multiply your A times your C. And that's whatever number that is, that's what you're going to put there. Okay. If you remember before when we factored, if you've watched other videos, when A was equal to 1, what I did is I had to find factors of C. Well, when A is equal to 1 and you're multiplying A times C is 1 times C, which is just C, right? So we're kind of still doing the same process here. We're trying to find all of our factors is what we're going to happen. Well, but your factors is going your factor A times C is going to go on top, and then on the bottom we're going to put B, which is that middle term. Okay, so let's fill this out. Let's go to the side and let's actually use this. Let's use the trinomial I have here and let's fill in the star and let's see what happens. My A in this trinomial happens to be a positive 12. So I'm going to put 12 on both sides of that star. Now the next easy thing for us to do would be to figure out what our B is. B. Our B is that middle term, and we can't forget the sign. The sign there of my B is negative 13. Okay. And on top, my A times C, well, my C is equal to a negative 35. So A times C is equal to 12 times a negative 35, which is a big number, right? And if I multiply that, 12 times 35, I'm not a human calculator, okay, is 420. So what I am looking for is two numbers that multiply to give me 420, but they add to give me a negative 13. So what I'm going to do is over to the side, I'm going to write 420, and that's actually a negative 420, right? So if it's negative 420, let's discuss this a little bit before I go any further. What does that tell me? Because my A times my C is negative. When I multiply those two numbers together, I got a negative number, right? So that tells me that I'm going to have one positive and one negative factor. That's how the math works, right? My factors, I'm going to have one positive and one negative. But because my middle term, because that B is negative, when you have opposite signs, the largest factor will always have the sign of that middle term. So because that B is negative, then I know the largest factor, guys, I apologize, I'm not sure. Sometimes my computer works well, other times it does not. The largest factor will be negative. So I have a few notes. I know I'm going to have one positive and one negative factor. And I know that when I figure out what my factors are in that list of factors, when I write them down, I'm going to take each one of the larger negative factors, and I'm going to make those negative. Um, and I like to work smart, not hard. 420 is a big number. I could go through a large list of numbers here. But what I noticed from the very beginning is that my initial factors, how did I get 420? I multiplied A times C. 12 times 35. 12 times 35 has to give me 1240. Let's make that largest number negative, guys. Well, what is 12 plus a negative 35? Well, that looks like it's going to be, it's 23. Now, it's not 13, but it's close. But what I did is I know somewhere in that area, there's no point in me starting in my small factors. Because my difference between those are going to be large. So let's start around 12. Let's take 420 and divide that by numbers around 12. We can do 12, we can do 13, we can do 14. So I have 14. And what we're looking for is a difference of 13. So 14 and 30. Now if I have negative 30, and I add 14 to it, that's going to give me negative 16. So that's not negative 13. So let's take 420 and maybe divide that by 16. That's not going to work. 420, I skipped 15. I have 15 and I have 28. That is a factor. And I know you cannot see me, but literally what I'm doing in my calculator, because again, I'm not a human calculator. I'm guilty, I'm not. But what I'm doing is I'm just dividing, guys. Um, and I just want to see what my factors are. And what I notice, again, remember my largest factors are negative. If I take 15 and I add a negative 28 or subtract 28, whichever way you want to look at it, what is my answer? What is the difference there? A negative 13. So I can stop. There's my factors that I'm looking for. So what I'm going to do is take those factors. Let's write it in black. I'm going to take those factors and I'm going to write them in those missing places in my star. So I have 15 here and I have negative 28 here. And I am nearly finished with this, but not quite. I'm very close. Guys, what you want to do is you want to look at that 12 over 15 and you want to look at that 12 over 28, kind of like a fraction. You want to simplify that. What we're doing is we're reducing these expressions. We want to reduce those expressions. So let me pick a color. Let's pick red. I don't have too many colors to choose from. But think about 12 and think about 15. What is the largest factor that will go into or divide evenly into 12 and 15? 3. 3 will go into 12 4 times. 3 will go into 15 5 times. Okay. So let's think about 12 and 28. So what is the largest number that would divide evenly in 12 and 28? 4. 4 will go into 12 3 times. 4 will go into it that negative 28 negative 6 times. And oh, I didn't simplify it completely, which is fine. And that's okay for me to do. And if that happens, fine. Um, so 6 is my largest term. Y'all, I'm sorry. I'm not teaching in front of you every day. But it's okay. If you reduce and you see that you can reduce again, then reduce again. So what would divide into both 3 and 6? I can reduce this again. Let's erase this to the side. I know that 3 will go into 3 one time. 3 will go into a negative 6 negative 2 times. So that wasn't completely reduced. I need the one that is completely reduced. So I'm going to circle what I'm going to use. And I know this is a lot, but this is the same process that you would go through factoring, or at least the way that I was taught many years ago to factor. So I have everything I need. I have my coefficients. Now what I'm going to do is place these in factored form. I'm going to I'm going to write them kind of large for you guys, my two sets of parentheses here. And I know my variable is a v, right? So what's going to happen is this is going to be 4v from this first set of parentheses. And because that's a positive 5, that's going to be plus 5. And then I have that 1 over negative 2. So that's going to be 1v, or just v, minus 2. And because we're trying to solve this equation, we're going to set this equal to 0. Let's go back to that 0 principle, right? The rule that we were talking about earlier. So that's what we're going to have to use to solve this. I'm going to have to take each one of these roots and I'm going to have to set these equal to 0 and I'm going to solve it. I'm running out of room. I'm running out of time, so I apologize. But guys, this will give me 4v is equal to negative 5. Divide by 4. V will equal to a negative 5/4. And on the other side, V will be equal to 2. So there, oops, is my two answers.